Children, today we are going to start a topic integration. We have studied differentiation. So differentiation and integration are almost linked. What we have studied in differentiation? Suppose if we differentiate any function fx plus c, then the constant will become 0 and the derivative of fx will be f dash x. Here I have written capital Fx. So integration, when we do, we can convert this fx into fx plus c. This is what about integration. Integration is the reverse process of differentiation. That means whatever function we obtained after differentiation, if we have to obtain a function before differentiation, then we'll take the help of integration. What was the function initially? So if we differentiate fx plus c to form fx, so if we integrate fx, that we'll get fx plus c. Alright. So that is why it is called antiderivative. It is a reverse process of differentiation. So integration has been divided into two categories: indefinite integration and definite integration. In indefinite integration, that's we have discussed antiderivative and opposite process of differentiation, and definite integral will get the particular value. So it is called the process of summation, adding the terms, right? So adding the sum, finding the sum. So this is called process of summation. That means that we'll study afterwards, definite integration. Okay. So now concentrate on the terms related to integration. So this is a sign of integration, right? Like differentiation represent d by dx. So that means dx means we are differentiating with respect to x. So this is a sign of integration. Whatever term we are integrating, that will be called integrand. Okay, dx means we are integrating this fx with respect to x, right? If we write dy here, that means we're integrating with respect to y. Okay. Suppose after integration we get fx plus c. So this fx will be called integral or primitive or antiderivative. So any term used, that means this is the result of the integration, and so c will be the constant of integration. Generally we don't get the exact value of the constant. Okay, suppose this is 3 written, so it will get 0. d by dx 3. We cannot obtain 3 exact value after integration unless until the points are defined. That we'll discuss afterwards. Okay, note down this much first. Okay children, now let's discuss few points which are related to the topic integration. In that, the first point is, what does the integration represents? So if we are integrating fx, right, and we are getting this small fx plus c. So what we say, that is a geometrical representation of a family of curve where f dash x we have represented as capital Fx for all x, right? So this is what this is representing. Geometrical representation of family of curve. Family of curve means, suppose the integration of 2x dx, when we do, what we'll get? X square plus c. So c could have any value, 1, 2, 3, minus 1, minus 2, right? So if we put the different values of c here, we will see that if we c equals to 0, we'll get the curve equation of curve like this. If we put c equals to 1, we'll get this equation of curve. If we put c equals to 2, we'll get this curve, right? And if we put c equals to minus 1, we'll get this curve. So for different values of c, the curve, the sketch of the curve will be different. If we draw the curve on the graph, that will represent different curve. But if we differentiate any equation of the curve, we'll get the same slope, right? Suppose you differentiate dx, d by dx of x square, we'll get 2x. d by dx of x square plus 1, we'll get 2x. d by dx of x square plus 2, again we'll get 2x. d by dx of x square minus 1, again we'll get 2x. That means the slope at a point on the curve is always same. So if we take any point x equals to x naught and draw tangent at that point, that tangent will having the same slope. So you can see that this every tangent at point x naught is inclined are parallel to each other. Okay, so the derivative of the equation of the curve is same, which is the slope of the tangent. Okay, note down this much first. Okay children, let's see some properties of indefinite integrals. Property 1 says d by dx of integration of x dx equals to fx. Why? Because this is what? Antiderivative and this is derivative, so both will get cancelled and will get fx. Next, integration of k fx dx equals to, k will come out, integration of fx dx, where k is constant. At the time of differentiation, we have studied that constant will come out and we will differentiate only the variable. Okay, so we will integrate only the function and when constant is with the function, right? Similarly, the third property says that integration of, in bracket, f1x plus f2x dx, so we can separately integrate like we used to do in differentiation, separately d by dx of f1 plus d by dx of f2. So here we can integrate integration of f1 plus f2x dx, so we can say that integration of f1x plus integration of f2x. Alright children, note down these properties. Okay children, let's discuss a few basic formulas that we are going to use in different integration. In differentiation, we have studied that d by dx of x to the power n is n x to the power n minus 1. Similarly, if we integrate x to the power n with respect to x, it will become x to the power n plus 1 upon n plus 1 plus c, where n cannot be equals to minus 1. Why? Because the denominator will become 0. Integration of 1 dx is x plus c, right? D by dx of log x is 1 upon x, right? Similarly, the integration of 1 upon x dx will become log x plus c, where x cannot be equals to 0. Integration of d by dx of a to the power x is a to the power x log a. Now integration of a to the power x will be a to the power x upon log a plus c, where a is greater than 0 and a cannot be equal to 1. Why? Because the denominator will become 0. The integration of e to the power x dx is e to the power x plus c. D by dx of sin x is cos x, so integration of cos x will be sin x, right, plus c. D by dx of cos x is minus sin x, so integration of sin x will be minus cos x plus c. D by dx of tan x is sec square x, so integration of sec square dx will be tan x plus c. D by dx of sec x is sec x tan x, so integration of sec x tan x dx will be sec x plus c. Similarly, integration of cos x cot x dx equals to minus cos x plus c, and integration of cosec square x dx equals to minus cot x plus c. So these are the basic formulas that we are going to use in solving sums in the next exercise. Alright, note down please. Okay children, now let's solve few sums, right? Here I have taken this sum in which it is given that evaluate integration of 1 upon x cube dx, right? So let's solve this. 1 upon x cube can be written as, if we take this term to the numerator, it will become x to the power minus 3. Okay, so when we apply the formula, integration of x to the power n dx is x to the power n plus 1 upon n plus 1 plus c. It will become x to the power minus 3 plus 1 upon 3 minus 3 plus 1 plus c. Minus 3 plus 1 is minus 2 upon minus 2 plus c. It will become minus 2 upon x square plus c. Alright children, let's see another sum. Here we have to integrate sin x into sec square x. Sin x into sec square x dx. So let's simplify first. Sec square x can be written as 1 upon cos square x. Right? Sec theta is 1 upon cos theta. So sec x will be 1 upon cos x. Sec square x will be 1 upon cos square x. So now when we simplify, we can write this 1 upon cos square as sin x upon cos x into 1 upon cos x. Just to convert into the format, or like integration of sec x tan x. So this term will become tan x. This term will become sec x. So integration of sec x tan x, what is the formula of integration of sec x tan x? It is sec x plus c. Alright. These are a few basic sums. This is starting of the chapter. Note down please. Okay children, let's see few more sums. Here we have to integrate 7 to the power x into e to the power x dx. right? So what we are going to do, we are going to write this 7 to the power x into e to the power x as 7e to the whole power x. So this whole term will become a, and we consider that it is written a to the integration of a to the power x dx. So what is the formula? What is the integration of a to the power x? Is a to the power x log a. So here it will become 7e to the power x, integration will be 7e to the power x log 7e, right, plus c. Alright children, let's see another sum. Now here we have to integrate under square root 1 by 2 in bracket 1 plus cos 2x dx. Let's simplify this square root first. So cos 2x, we know the formula in terms of if when we have to cancel this 1. So cos 2x formula we are going to apply is 2 cos the square x minus 1. Why particular this formula? Because by this formula this 1 will get cancelled. We have to simplify. So this plus 1 and 1 minus 1 will get cancelled, and when we open this bracket, this 2 and 2 will also get cancelled. Under square root cos square x will be cos x dx. So integration of cos x dx is sin x plus c. Alright children, note down please. Let's see another sum children. Here it is given that integrate 1 upon 1 plus cos sec x with respect to x, that is dx. Let's simplify this term first. Integration of cos x 1 upon sin x. So it will be 1 upon 1 plus 1 upon sin x. Taking the LCM in the denominator and doing the reciprocal, we'll get integration of sin x upon 1 plus sin x. Now multiply with the conjugate, okay? So the conjugate of 1 plus sin x is 1 minus sin x. So we'll multiply the conjugate, numerator and denominator. So in numerator it will become sin x into 1 minus sin x, and denominator will become 1 minus sin square x. 1 plus sin x into 1 minus sin x is 1 minus sin square x. So 1 minus sin square x is cos square x, right? So this will become sin x upon cos square x 1 minus sin x. Let's multiply this term inside the bracket. This will become sin x into sin x upon cos square x dx minus sin x into sin x will be sin square x upon cos square x, right? So sin x upon cos square x is sec x tan x when we convert into sec and tan, and sin square x upon cos square x will be tan square x, right? And tan square x can be written as sec square x minus 1. Alright. So integration of sec x tan x dx is sec x. So we'll separately integrate integration of sec square x dx plus integration of 1 dx, right? So it's sec x minus tan x plus x plus c, right? So this is with the solution of the integration of 1 upon 1 plus sec x dx. Alright, try to learn how to simplify, okay, and then convert into simple formulas and then integrate, right? Note down please.